There we go. Now we're recording. So, downstairs in the lab, we were playing with the high voltage meters. We're looking at electrical systems. We're figuring out how the meters work, right? We're doing okay with all of that. When it comes to the actual subject matter, some of you guys last year in EV1 didn't get the full experience. Some of you guys in EV2 didn't catch up, didn't realize, and that's okay. So what we're going to do is we're going to go way back to fundamentals, and we're going to draw this out in a really simplistic form so everybody understands it, so we get it, right? We're going to draw lots of pictures, or I'm going to draw lots of pictures. You can either draw along if you understand it. If not, stop me and ask me a question. Maybe we're going to get to it. Maybe I've forgotten it, okay? From there, we're going to look at a whole bunch of different questions that we might have. What is a high voltage system? We're going to go into a little bit more elaboration on what is a high voltage system. Mainly, what differentiates it from a regular electrical system, not just the voltage. Of course it's high voltage, it says it in the name, but it's configured and wired differently than what we're used to when we're working on 12-volt systems. So that screws us up a little bit. We're going to look at how it's wired in the car. We're going to simplify it. We can look at wiring diagrams that are horrendously complex or different takes on them. We're going to make it super simple for easy comprehension, okay? We're also going to look at expected measurements of it. So when I send you out of here, when you shut down a system or when you play with a live high voltage system, using appropriate PPE of course, your measurements are going to just absolutely blow your mind because it's not what you're used to on 12 volts, aside from it being ridiculously high voltage. What is going on when we make one of these systems safe? Right? We know we shut off the high voltage system. We've been through year one. Somebody showed us the measurements or we did the measurements ourselves and it appeared to be safe. Well, what happened? We're going to look at internal components to the battery, not pictures, just fundamentals. You've heard the word contactor over and over and over. What is it? What is an MSD? How is it tied into the battery? What happens when I remove that orange switch? We're going to look at inverter and inverter operation really quick today. We're going to look at an auxiliary electrical system, and we're going to discuss why we have 2 or more electrical systems on these cars. We're going to look at how it's stored in the battery, how the power is stored, and we're going to look at why do we run high voltage accessories. Accessories are DC to DC converters, AC systems, heaters, all that kind of stuff. And we're also going to see how that's incorporated into the high voltage system. So I want to take a real 1,000-foot down approach, top down approach, and look at kind of everything that we're looking at and everything we've talked about up to this point. To begin, let's begin really simple, and we're going to start off with the battery itself. The battery is like a fuel tank for an average car. It's an energy storage system. That's all it really is. Right? So in my drawing of drawings here, I'm going to start off. We're going to draw a battery case here. There we are. Just like so. Nothing too complex yet. The complexities come later. And of course, any good battery is going to have cells in it, right? We're okay with that? So we'll start off, I like positive on the top. Got to be positive first, and then a little bit later on will be negative. Here we go. So we'll start on positive here, negative, positive. We can see those are cells. Does the chemistry of the battery matter for this example? No. No, if it was going to matter, I'd tell you, I don't care at this point. There we go. So, in here we've got 2 banks, or 2 sections of cells in the battery I've got. I want to get arbitrary numbers, something that's easy to work with, okay? How high a voltage do you think this battery should be? What do you think is average? What do you say?
48.
48 volts. High voltage. Not. What's that?
12.
High, high.
240.
Okay, 240, what are you saying? 300? I'm gonna go right in the middle. Right in the middle of our potentials that we have in automotive, kind of what most systems in full electric vehicles are centered around. And we're gonna make this guy 400 volts. Something like a Porsche or a highway tractor, it might be 800 volts. Something like an Audi simple hybrid, it's gonna be 48 volts. Okay, so we've got this full gamut, this huge range. But most of the time with most of the electric vehicles or electrified vehicles, we work on somewhere between 300 and 400 volts. Lots of potential, lots of snap. All right, so if we just wired up this battery, we tie the wire from here to here. Don't draw this wire because that wire is going to be erased, it's going to be removed. We just drew this wire and we put all these cells in here, and we took our multimeter, don't draw this multimeter, and we went from here to here. Our multimeter would show 400 volts. Does that make sense? Cool. So I'm going to take that wire out, the one I told you not to draw. How many volts would my multimeter show? So it no longer is connected here to here. What do you say?
0.
0. 0 volts. Why? Why does it show 0 volts when I remove that wire?
Short.
Different. Open. There's no path for current to flow. It'd be no different than trying to measure the battery like that. Right, we're missing that connection between them. Okay? So, neat. Let's hook up the first piece of the battery that you ever really look at, that you're drawing attention to, that somebody shows you. Okay? The very first piece of the battery is going to take place of that wire. We're going to put it in from here. Just like that. So now we've got a couple of wires sticking out of the battery, and on top of those wires, still got it, we're going to join them together, and of course in order to join them together we're going to use terminals. Nice and easy, just like that. And we're going to put what's that? Mr. Squiggles there. Who's that? It's a fuse. We are fusing the battery. It is the main fuse. Did anybody in Auto 120 tell you about fusible links? Right? Giant fuses that protect the whole system. Mega fuses. The great big fuses. That's basically what that is. It's a mega fuse, maxi fuse, whatever you want to call it. It's a single fuse to protect the whole system. Sometimes it's here, sometimes it's in there, but there's going to be a fuse somewhere just in case. Just in case we get a dead short of the battery. Just in case we're going to flow too much current. Then I'm going to create the plastic housing for this thing. I heard someone say it, I think. What is that? It's the MSD. So the thing that you take out of the battery, that handle that you flip and that little orange piece that you pull out of the battery is the wire that joins the top side to the bottom side of the battery. When you tickle that thing, when you stick your fingers in it, you are literally touching both sides of the battery at the same time in the middle. There's some danger there, right? Can I turn off a battery? I can't turn off a battery. All that this does, this doesn't turn off the battery. It opens the circuit between one battery and the other. 200 volts plus 200 volts in series equals 400 volts. If you want to see the same thing on a smaller scale, who plays Xbox? A couple people, or once upon a time we used to have one? Who's got a TV remote? The batteries inside the TV remote, right? One goes up, one goes down. One goes up, one goes down. Each one of the batteries in your TV remote is 1.5 volts, but put in series, they run on 3 volts. That's all this is a giant TV remote so far. All right? Except with a handy dandy switch at the end. That's the entire energy storage system inside of this thing. But we know that when we hit the button on the car, the outside of that battery case no longer has voltage. Right? The 2 points that you tested at showed 0 when you got to play with them. How does it show 0? That's weird, right? So, after these cells here, we go into our positive and our negative side of the battery. What color are the cables? High voltage cables, what color? Orange. In my drawing, in order to differentiate positive and negative, negative will be black, positive will be red. Just because it's how my 12-volt line works. Is everybody okay with that? Okay, cool. So on the negative side, we're going to come out of the cells, and we're going to create an open going outside the battery. Positive side, we're going to come out of the cells, and the same thing, we're going to create an open going outside of the battery. When you turn off the car, there's a state of things. The battery inside, still spicy? Yep. The battery outside, spicy? Absolutely not. So that's great for being turned off. However, I don't want to be turned off when I want to go somewhere. Would have been really inconvenient if I pressed the button on my car this morning and it didn't close the contactors. The contactors, you've seen this symbol before, whether you know it or not. That symbol looks like a momentary switch, right? Where you press it down and it bounces back up. Of course, we're going to have one of those on either side. Here we go. So we've got our momentary switches. Anybody sticking their fingers in there and trying to hold them down while you're driving? That doesn't work very well, right? So those momentary switches, in order to open them back up, once we're done, once we turn off the key, I don't want them to open with electricity. I want them to open on their own. I want them to be normally open switches. All right? So, when they're open like this, it's on spring pressure. As soon as I remove electrical flow to the control circuit, they go click and open up. Which means I need a control circuit to close them. My control circuit, you know what? Let's change color here for a second. How do we feel about blue for being 12 volts? We're okay with that? So, for today's lesson, we'll go anything 12 volts is blue. Good? We're going to create that's looking good. We'll get to this box here in just a second. We got some weird wiring going on there. That's okay. This guy's going to be our BMS. BMS is battery management system, okay? So it's a little module in there, there's lots of stuff going on. Point being is, EMS right now is controlling coils. And it's controlling the coils on 12 volts. So instead of using my fingers to hold down those switches, I'm going to be able to use my 12 volt system to hold those switches down when I'm driving the car. What else operates like that? Uses like a low current to control a high current. Auto 120. You learned all of it. Pin 85, 86, 30, and 87. Relay. Right? How many contacts move back and forth in a relay? How many electrical contacts between 87A, 87, and 30 actually move? We could draw a relay real quick. So, 5, 6, between there we got that, right? And our outputs are 87, 87A, and our input is 30, and it comes down, go over here, and out, or here. How many things actually move in that? Just one, right? It's just a switch. Goes between 87A or 87. One's normally open, one's normally closed. If I got rid of 87A, it was only a 4-pin relay, and yeah, you'll see them lots. Boom, now I have only one click, click, click switch, right? There we go, and we'll do our little, there, those are the points that connect. How many points connect here? 2. Yeah. Relay, contactor. It's pretty sexy, isn't it? Easy. 1 moving point, it's a relay. 2 moving points, for our argument's sake, we're going to call it contact. And just to make it all sexy, you know what we're going to do? We're going to put this dashed line around it. Yeah. Which tells me that it's a component, right? We could probably put a solid line around them, but I'm not that confident this morning. There we go. So this guy at the top, we're going to call this main. Main positive contactor, which means the one at the bottom is, you got it. So let's go all the way back. You guys have all been through this course, right? Anybody not? Anybody taking this for the first time? Okay, wicked. Did you take the prerequisite, 129?
The other one,
The truck and coach one. Okay, cool. So far, old news, new news? New for you. Okay, what about the rest of you? Clearing anything up yet? When we shut off a car, we take measurements. We take measurements here and here. It doesn't matter where our test locations are. We are taking measurements from here and here. It might be at the battery. It might be at the other end of the car. If I look at this and this alone right now, I take measurement from here to here. How many volts should I see with the car off? 0, right? How come? It's open. There's 2 opens right there. It doesn't actually touch. You may as well hold the multimeter like this. I can't read the battery like this. It's because you're not touching. Likewise, we go and those are our 3 test out tests, right? Positive to ground, negative to ground, positive to negative. And everything you want to see, 0 volts, 0 volts. What if this guy didn't open up? It was stuck closed. What would I see? How many volts? Yeah, nothing, because this one's still open. If this one was stuck closed and that one was open, 0, because I've still got an open in my test circuit. What is the likelihood that the car is functioning with both of those stuck closed? It's not very good. I'd have to have a double or triple component failure in order for those to get stuck. As well, when I'm checking for no voltage, what else is missing from this whole picture? So when we shut down a car, 1 open, 2 open, 3 open. Man, that's a lot of personal protection, isn't it? Huh. When I turn off a car that is functioning correctly and there's no battery codes, what is my risk to my person outside the battery? High or low? Very low. Incredibly low. The battery, though it is a danger, if we follow the shutdown procedure and make sure the car is off, it is a very low danger outside the case. Can't kill yourself yet. My God, the redundancies. So good. All right, so far, we understand this energy storage. How is energy stored in those cells? AC or DC? DC. DC. Can I store AC in that battery? What if I introduce AC to that battery? How's it going to go?
It's going to change to DC.
It's going to be angry, right? Because you're pushing and pulling on those cells, you'll overheat them. So we don't want AC there at all. So anytime I'm measuring a high voltage component with 2 cables in it, it is going to be DC. If I'm measuring a battery, it is going to be DC. So we know that this 400 volts is a D with a C. Just like the comics, but it doesn't mean the same thing. Okay? That's directional current, not detective. Okay? We're good with that? Cool. Cool. So far this thing isn't scary, is it? That's the complexity of a battery so far. How many contactors do I have?
3.
3. In this example so far, I've got 2 of them. We'll get to the 3rd one in a little bit, okay? And it has to do with the rest of the system. That's why I'm not jumping to it quite yet. Not all vehicles have 3. I can have more, which is very common now. I can also have less, which is really uncommon and is very kind of old, early 2000s, GM, Honda junk. So we're not going to worry about that. What I'm going to say, if I ever ask you on a test, is minimum of 3 contactors. Again, we'll get back to that. So, what have we answered so far? No, we didn't. No, no. Contactor and an MSD. We figured out what those are. Should I test from an MSD? Test from the orange plug right here. Back of the battery, I take it out. I've got 2 terminals sticking up in the air like this. Should I test them?
Sure.
Okay, so you say sure. Let's take the MSD out. Whoop, it's out. Okay? I'm going to test at the MSD. I like it. I like the sure. The sure made me feel good. So I tested the MSD. I do 1 terminal with a voltmeter to ground. I do another terminal with a voltmeter to ground. And I go from terminal to terminal. Car is functioning, yes? How many volts does that show?
400.
Does it?
Oh, no.
Oh,
Yeah,
shit.
It has to be going through the fuse.
Does it? Is the battery connected here?
No.
Oh, fuck, it shows open. It shows 0 volts at all those connections. Is this battery turned off? No, the battery's not turned off. I can't turn off a battery. Is there 200 volts here and 200 volts there? Yes. Did the meter tell me that? No. Is that a good reading?
0, yes.
It tells me that there's 0 volts here. Is that a good reading? Then I touch that terminal. Now there's not 0 volts there anymore. That is not a good reading. As well, does it tell me how many volts are here? I just finished saying that when I turn off the car, the likelihood of me being hurt by the battery out here, pretty low. But I still test out here. That means out here, there's something else that's trying to bite me. It's not the battery I'm usually concerned about. As well, if I touch this and there's a short in the battery case, a lot of the time, what am I leaning on to take that measurement? The battery case. Next thing you know, I put myself at undue risk leaning on a battery case and touching a live terminal. Do not test here. Why? 2 reasons. Incorrect readings. Boom. The next one is connected directly to battery cells. So none of these are good, right? You can electrocute yourself or not know that you're going to electrocute yourself. Son of my itch. That's what we call a no good. He doesn't sleep, eh? This is the only spot he gets rest. That's a shame. Shame. All right, cool. So far we're doing pretty good on the battery. Let's take this. We'll see if we can get him a coffee. Take 5 minutes, and then we're gonna go outside the battery. So take a break, throw a dart, whatever it is that you guys need to do. I'm gonna hit pause on the recording, and then we'll take a break, come back, keep going. Sound good? Go. 8:48, I'd like to be back by 9 if we can. A disconnect, a removable wire if you will.